Alright guys, so today's lesson will be our trickiest lesson yet on exponents, and I know that probably sounds pretty intimidating given that exponent stuff is already pretty hard. And just to make sure y'all that I had to teach y'all this and that it wasn't a standard that I could put off till next year when y'all are taking your final math class, it is right here, Algebra 2 State Standards. This is on their website, Tennessee website. I just double checked just to make sure that it's still an Algebra 2 standard. And it's right there, A2.N.Rn.A1, rational exponents. All right, and I know, so it will be a little bit confusing, guys, but like anything, it's just practice. The hard part is when you add it on top of everything we've already done. So first of all, please make sure that you have done everything that up till now on Delta Math, that you have practiced all of the exponent homework on Delta Math that you should have already done before you do this lesson, because otherwise it will just be super confusing. Alright guys, before we get going, first of all I wanted to mention that I know on the Delta Math problems, sometimes there were some problems that had like 2 to the 5th, for example, or 3 to the 5th, or 4 to the 4th, which I definitely should have had on here. So I apologize that wasn't already on the chart, but hopefully, of course, you realize how to get 2 to the 5th, right? Given that you know what 2 to the 4th is right here, well, you just times by 2 again, right? 32. 3 to the 5th times by 3 again, right? Or just type it in a calculator, 3 times 3 times 3 times 3 times 3, 5 times, 243. And 4 to the 4th, that would be 256 if you times by 4 again. Yeah, now, again, guys, I do want to minimize how much you have to use a calculator, so not a bad idea to go ahead and add those to the chart. But, of course, you could keep going, right? There's no rule that you can't have 4 to the 5th, 4 to the 6th, or anything like that. Or, of course, 4 to the negative 4th would just be 1 over 256, right? So, again, go ahead and add those to your chart if you would, or just be aware that you can, of course, always get the next power by just continuing to multiply, of course, right? All right, guys, so for today's warm-ups, I've got 4 problems here where I want to address a few things I saw while helping students do Delta Math yesterday. So I'm going to go over them one at a time. So first of all, just go ahead and try number 1 on your own. And then enter your answer, and then I'll go over it. And then I actually am going to go to number 4 next in order to contrast these two. I've realized I should have done this one second, but that's okay. We'll do this one, so go ahead and try it, go over it, and then we'll do this one, and then we'll do these two. All right, so number 1, guys. First of all, we have to deal with the parentheses first. That means we ignore this negative. It's not in the parentheses, right? So this negative outside here does not get the third power, nor would anything else outside get the third power. So I just really ignore that negative for the moment. All right, what's going on in parentheses? First of all, there's a negative getting a third power. A negative getting an odd power stays negative. 2 gets a third power. That becomes an 8. Don't forget to give 2 the third power, y'all. Very common mistake. X gets the third power. That's cleaning up the parentheses. Now I have to bring this negative down. So the 2 negatives here, right, now that this negative is brought down, now that the parentheses are cleaned up, the 2 negatives here will cancel out, right? So they're just gone, they're positive. So this is my final answer, 8x to the 3rd. All right, go ahead, guys, try number 4 now on your own. All right, number 4. So inside parentheses only gets the square, not the negative this time, y'all. The negative does not get the square. It is not in the parentheses. So 3 gets squared, that's 9, don't forget to square it. X gets squared, and now I bring down the negative, boom, because it did not get the square, so that's my final answer, right? If the negative had been inside of the parentheses, right, if it had been on the 3 getting the square, then it would turn positive, right? If it had been here getting a square, it would be positive, but it was not inside parentheses, stays negative. All right, go ahead and try number 2 for me. All right, so the big mistake, guys, on number 2 is that when students correctly do this part, they do 2x, and then they go 2 minus 6 is negative 4, right? And then there's a couple mistakes that students make. So remember, guys, for Delta Math, we need to have positive exponents, so that means we have to make this guy happy, right? So we have to flip it down to here, right? Now, the mistake is that students will bring the 2 with it, and they'll put the 2 down here. But the 2 is chilling, guys. The 2 does not get the negative 4. Only the x gets the negative 4. The 2 is chilling where he is, so in this case, we don't have a placeholder 1. We just leave 2 up in the numerator where he is, only x4 goes down, right? And then, of course, the other thing that students get confused about is they might have written, instead of written this, they might have written this, 2 over x negative 4, right? Because they said, oh, or maybe they wrote 2x4 because they did 6 minus 2 because that's bigger. But guys, that's not the rule. It's not the bigger minus the smaller. That is not the rule. It is whatever is on top minus whatever is on bottom, right? So 2 minus 6 is negative 4. Now I make him happy and I bring him down, right? So don't try to do too much at once where you're like, oh, he's going to be unhappy and I'll make him negative 4 and bring him down, because that would be wrong, right? Because once we bring him down, he's actually positive, not negative. So again, don't do big minus small, just do top minus bottom. If your answer is negative, then make it happy and bring it down. So another thing is students are trying to do things in one step. Guys, look, this is my first step, this is my second step, right? Don't be afraid to have as many steps as you need to show every step of your cleanup process, all right? So don't ever be afraid to show more steps than is, however many you want. There's no rule on how many steps you show. So don't try to do things all at once. And then finally, guys, I want to point out, remember how I showed you at the beginning, if you can always expand stuff out, right? So if we expand this out, what we have is 2xx, right? 2xx divided by x, 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 x. 6 x's, right? We have 2xx divided by x to the 6. 6 x's. So that one will cancel with that one. That one will cancel with that one. What am I left with? A 2 on top and an x4, right? 4 x's, 1, 2, 3, 4 on bottom, right? So if you ever get confused, if you ever get super confused, just expand it out, right? The reason we don't always do that, guys, is because it's just not, that's just kind of silly, right? That just takes way too long to do for every problem, especially if these are big numbers, and it makes more sense just to use math. 2 minus 6 is negative 4. Make it happy, all right? Instead of having to do that. But you can do that if you get confused. All right, final problem, guys. Go ahead and try it, and I'm going to go over it. So the big mistake I see here is students do the following. They say, oh, 2 over 4, that reduces. Boom, boom. I can divide both by 2. That becomes a 1, that becomes a 2. No, you cannot do that, guys. The reason you cannot do that is because this 2 is not just a 2 that's just chilling, right? This 4 is just chilling, but not this 2. This 2 is trapped inside these parentheses getting this third power. Guys, the rule is you have to deal with your parentheses first before anything else, all right? So parentheses always comes first, and in this case what that means is 2 has to get the third power, so you cannot reduce this, right? Very common mistake is to just try to reduce this or cancel this right away. You can't, nor could you cancel the x's right away, right? You have to deal with the parentheses first. So 2 gets the third, x gets the third. We have 4x on bottom, bring it down, right? Whatever you don't mess with, guys, whatever you don't mess with, just bring it down. And now I'm going to clean this up. So I have 8 to the third, x to the third, over 4x. Now I can reduce 8 over 4 is 2 over 1. And then I have 3 minus 1, right? 3 x's on top, minus 1 on bottom. 3 minus 1, get rid of that. So I have 2x squared. 3 minus 1 is 2. All right? So guys, again, here I showed you one step, or sorry, this was the original problem. 1 step, 2 step, final step, right? As many steps as you need. And remember, guys, parentheses have to come first. You cannot cancel what's inside parentheses with something else. All right? What's inside parentheses has to be dealt with first. Alright guys, so I've noticed that a lot of people are definitely having trouble with just even the idea of what is a square root, and I think just a lot of people just kind of missed that, or just with the last year and a half or whatever, didn't get covered as much. So let's just review what exactly a square root is for a minute, right? So, as y'all know, 5 times 5 is 25, right? And the other way to write this, of course, is to say that 5 squared is 25, alright? Now, square, of course, y'all, is different than times 2, right? It's a different operation. Why will my camera not focus? There we go. It is a different operation, right? So, in math, guys, every operation comes with an inverse operation, an opposite operation, right? Plus comes with minus, times comes with division. Well, square comes with square root. So 5 squared is 25. Well, that means that the opposite of squaring 25 is square rooting 25 to get 5, right? It's literally square root is just the opposite of 5 squared. Another way of showing it is that a square root of rewriting 25 as 5 squared is to say that the square and the square root cancel each other out, right? And you're just left with 5. And of course this applies to, any number. 2 times 2 is 4, 3 times 3 is 9, so the square root of 9 of course is 3, and so on. Alright, now the reason I'm reviewing that is because we're going to step it up a notch. So just like we have square roots, we can actually keep going. So 5 times 5 times 5, right? So that's 25 times 5. So if you have 5 quarters, y'all, that's $1.25, right? 125. So 5 times 5 times 5 is 125, which I'm going to rewrite 5 cubed is 125, right? 5 squared is 25, therefore the square root of 25 is 5. Well, 5 cubed is 125, therefore the cube root of 125. So what is this asking, guys? This is asking what number times itself 3 times gives 125. 5 does. Alright? So here's the deal. We can keep going with this cube root stuff. We can keep going to 4th root, 5th root, and so on. Square root, guys, is the only one where we don't put the number right here. But you could. Right? You could write a 2 right there to indicate that it is a square root. As far as I know, that is the only invisible 2 in mathematics, right? Normally we talk about invisible 1s, but that's an invisible 2. Now, for any other type of root, right, because you can keep going, 3rd root, 4th root, 5th root, you're going to put the number right here, which is often called the index, all right? So that is a cube root. Another way of showing it, y'all, cube root of 5 times 5 times 5, right? Because, again, that is 125. Is just, again, asking what number times itself 3 times gives 125. 5. Alright? Or again, cube root of 5 to the 3rd. The cube and the cube root cancel, and you're just left with 5. Alright? So let's try another one. So let's just pick a number like 3. So 3 times 3 times 3, in other words, 3 cubed, that's, of course, 9 times 3 is 27. So therefore, the cube root of 27, right, doing the opposite of cubing, the cube root of 27 is 3, because 3 times 3 times 3 is 27. The cube root of 27 is just 3. Alright, let's even look at a 4th root example. So 4 times 4 times 4 times 4. Alright, so that's 16 times 4 is 64, times 4 again is 256. Right, so therefore the 4th root of 256 is 4. Right, because 4 4s make 256. The 4th root of 256 is 4. Now let's rewrite our exponent properties again, because again, guys, this is the kind of thing that you will just have to have memorized for our test on this material. So it's worth just writing them all out again. Alright, hopefully you got most of them down by now. B to the 0, B to the S times B to the T, B to the S divided by B to the T, B to the S all to the T, B to the negative 1, and then I'm going to add one final one. Alright, so go ahead, pause it, fill this out for me real quick. Hopefully you've got it all memorized. So B to the 0 is 1, B to the S times B to the T, base times base we add, base divided by base we subtract, S minus T, powers of powers we multiply, negative exponents, guys, don't confuse it. It doesn't make it negative, it just flips it. Oh, and I should always add, I kind of forget it, negative base to an even turns positive, negative base to an odd stays negative. Alright? And then finally, our final property, alright? So this is the one that, the reason I reviewed this square root stuff and cube root stuff is for this final property. So the nth root of b is equal to b to the 1 over n. Alright, and I know this is confusing at first. It is almost certainly the first time you've seen it, so I know it will be confusing at first. Alright, but this is our property, key property for today. And it is very easy to confuse it with other properties, right? Which is why I gave you so much practice with the delta math, these other properties. But we're going to practice this till it makes sense, alright? So, for example, the cube root of, let's say, 8. Alright? I'm going to change it from this radical form to, well, this form has several names: exponential form, also rational, or fractional form. And that is to say that the cube root of 8 is the same as 8 to the 1/3. And I know this is confusing at first, but we're saying that the power here is a fractional power, and it does start to make sense if you look at it, if you work with it a little bit. The cube root of 8 is 8 to the 1/3. Alright, these are the same thing, two ways of writing the same thing. To be honest, this way is a lot better, and I honestly wish we didn't have this way of writing it at all, right? Because this way is actually better. Now let me show you why it makes sense. So imagine for a second that I had 8, which is 2 times 2 times 2, right? Or 2 to the 3rd. Now imagine I have 2 to the 3rd, and I'm taking the cube root of that, right? The cube root of 2 to the 3rd. In other words, the cube root of 8. Well, the cube root and the cube are going to cancel each other out, and you're left with just a 2. But now imagine I'm using it in the other form that I just showed you, this fractional exponent form. So I have cube root of 2 to the 3rd is the same as 2 to the 3rd all to the 1/3, right? Because here's why this is the same thing, right? The 2 to the 3rd part hasn't changed, and I've changed it from this radical form, cube root, to fractional or rational exponential form, cube root, 1/3 exponent. These are the same thing. Now, what is the rule, guys, when you have powers of powers? You multiply. Well, what happens when you do 3 times a third? 3 times a third is equal to 3 over 3. 3 over 3 is, of course, just 1, 2, right? Cube root of 2, we want to cancel out and leave just a 2. Well, that's exactly what happens when we use exponent rules. 3 times a third is 1, leaving you with just a 2. So it makes more sense to use fractional exponents instead of radicals. It actually makes a lot more sense. It's cleaner, and it's how we do calculus as well. So it's actually the better way to do radicals. Alright, next, guys, we're going to look at a bunch of examples of just changing the form. Alright, we're not going to try to simplify or solve or anything. We're just going to change the form. Alright, so the key here, guys, is that both 8 and x need to get the cube root. So they're both going to go in parentheses, 8x. Cube root is going to become 1/3. Alright, a way to remind you of how to draw it, guys, how to write it out. Where do roots go? Roots grow on the bottom of trees, right? Well, so the cube root goes to the bottom. Alright, next one. Again, xy squared both of them are under the radical, so they both need to go in parentheses here. Alright, and then finally, even if it's something tricky like a fraction, same deal. We put that whole fraction in parentheses, and I totally messed this one up. Guys, that's not supposed to be fourth power. That is supposed to be a 1/4, right? Not a fourth power, but a fourth root. Alright, back to this one. Fifth root, y'all, 1/5. Alright, and let me show you a couple other examples. So let's say we had x to the fourth power, and then we were taking the eighth root of that. Alright, so how would I change the form on this? Well, I would keep it as x to the fourth, because that's still the power. The root would go down. Alright, now, guys, regular rules of fractions still apply to this exponent. 4 divided by 8 reduces 1/2. Alright, so it turns out that the eighth root of x to the fourth is the same as x to the 1/2. Now, speaking of 1/2, this is kind of the trickiest thing. A square root, y'all, a square root of x. How do I change the form on that? Well, what's the invisible power right here? 1. And what's the invisible root right here? 2. So how do I change the form? Well, I keep the x the same, still the same base. The power is up, the root is down. So y'all, x to the 1/2 is the same as the square root of x. And this is literally the most important one, but it's also literally the most forgotten one, for the one simple reason. Because when I write the square root of x, y'all, look, the 1 is invisible and the 2 is invisible. You see what I'm saying? So students always forget this most important one. But it is literally the most important one of all. The square root of x is the same as x to the 1/2. Alright, let me just show y'all one last example of changing the form. Let's say you had something really funky expression like x squared cube root of y 5. Alright, technically this is a perfectly fine expression. It just looks very funky, kind of complicated. How would I change the form? Well, x squared is fine. It's just chilling. I just got to change the form on the y5 cube root. So I'd write y, keep the 5 as the power, the root goes down. Alright, so the x squared was chilling. The cube root here only applied to the y, so I don't put parentheses around it, right? Because the cube root is only on the y5 here. So the y keeps the fifth power, gets divided by 3 for the cube root. Alright, so guys, today on Delta Math, basically all you're going to be doing, practicing a little bit with radicals and practicing changing the form. Alright, just changing the form. And of course you could also go in the other direction. So like let's say I had the expression 2x to the 1/2 and ask you to change it from fractional form back to radical form. Again, remember guys, 1/2 as an exponent is the same as square root. It's the most important one. 2x would go under the square root, right? Because 2x both gets the 1/2. Let's say I had 3 times x to the 5th all to the 1/3. Well, 3, guys, is out here chilling, right? It's not trapped in the parentheses. So I'm just going to rewrite it. 3. 1/3 becomes a cube root. X to the 5th goes right in there. Alright? And finally, one last one. Final example, I promise. X, y to the 2/5, let's say. Alright? So again, x, just chilling. No parentheses. So x will just be chilling. Just x. Y, well, I got to change that 5 to a 5th root. Y squared goes underneath, right? So x here is just chilling, not under the radical. Y gets the square, and the 5 goes from the denominator here to the radical. Alright, so we kind of call that frequently, that's called the index.